JWTs, JSON Web token. What is a token, right? So, and again, that's going to be basic for a lot of you, but bear with me for half a minute for those who are not, who don't know auth and etc. So the main reason we need tokens is that we have a user, right? So that's you, consumer who wants to use their mobile app or something, and we have that mobile app or web app or something that needs to work on behalf of that user, and there's probably some sort of an resource API with which that app needs to work, right? So that's the fundamental problem. And then, so you need to get this app to work with this resource. So the traditional way is just, let's give this app username and password. And the problem with that is that this resource will now not know that this is an app. For that resource, any app that is working on your behalf is going to look exactly like you. Right? That there's no way for the resource, like that app gets full access, full power to do anything it wants on behalf of you. And it's okay if it's sort of a legitimate app, but you never know, right? So if you give each and every app in the world access to your whatever, to your email backend, then any app can do anything. They can leak your credentials, and there's no way to say, I no longer want this app to do anything, because you can only do that by removing access for everything by changing your password. So it's a very bad way. It's basically all or nothing approach. So usernames and passwords are bad in terms of delegating that access. So that the whole idea of tokens is that let's give that delegation ability. And the whole idea behind auth is that instead of username and passwords, we'll just give some tokens. So the way that it works, and as again, I'll show it as an example using code grant. There are a few different auth grant types, but it doesn't matter. It's not an auth talk. It's basically user, like I want this app to do something on my behalf. So I tell this app, well, I want to log in. The app doesn't know me. The app cannot log me in, but the app knows someone who knows me, identity provider. And that's what you see if you log in with Facebook, for example. It's very explicit, right? That the app redirects you to Facebook. So you see that it's a different thing. But even within one system, it could be some other service. So the app redirects you. And then this identity provider directly asks for a username and password, right? So that client app doesn't see that. You just talk directly to whoever is authenticating you. And that's actually very good, because whatever two-factor authentication on anything that is implemented here just works, right? So you can get authenticate with anything. Say username, password, then your second factor, whatever. So you authenticate, and then you often see that consent screen. I want to grant whatever ability to post to Facebook or ability to see my email address or something, right? So there's a consent screen. You say, yes, I allow that. And then this thing sends back now to that client app, sends authorization code, which is some unique ID saying, yes, this authentication got through. And then this thing, this client app then sends that authorization code along with its own credentials, right? So app itself can have some credentials. So now this identity provider knows that this app is a legitimate authorized app, and it knows that the user has authenticated. So it knows that the user is legitimate and that the app is legitimate. And it sends you the token, right? And then this token is what the app can use to access the APIs. Right? So this is auth, and this is why this part of it is what we're going to be talking about. Right? But that's the overall context, why tokens are needed and why tokens are so prevalent, why all application and API authentication these days is most of it, whatever, 99% is token-based, right? So we have that usernames and passwords and second-factor authentication and all of that good stuff is being used when humans are involved in that initial phase. Once the human has agreed to delegate some access and control, it's all just tokens, right? So that's going to be the content of the session is that going to be that thing. Oh, and obviously API response, hopefully. Anyway, and tokens can be anything, right? So basically, actually, auth standard doesn't say anything about tokens. So that's an interesting thing. Like the way that auth as a standard has been implemented it doesn't say what tokens are. It can be whatever, right? This is some sort of unique user ID that I've generated for this PowerPoint. It can be anything. And actually, OAuth standard doesn't say how that, if we go back, how that resource then figures out if it's a legitimate token or not, right? So that token gets sent, and then resource needs to figure out is it legit or not. For example, I could potentially have some sort of a database to which identity provider writes that unique string and saying, well, if someone comes with this string, it's whatever, it's John or Jenny. And then this API could use the same database to look up and see, yeah, that's Jenny. Something like that. So the standard doesn't say anything. However, people thought, OK, so why do I need that database? I have the ability to just send some information in that token. If token can be anything, why don't I just send the identity of that Jenny right in the token? Makes sense, right? I can send in the token, I can say, yes, this is Jenny. And in that case, you don't need that shared database. You don't need that identity provider and that resource to have anything in common. They can be completely decoupled if I just put everything, all the information in the request. So that's, and obviously the easiest way these days to put some information is in JSON. And that's just for purely pragmatic reasons. For developers, JSON is easy. All modern programming languages and frameworks have built-in JSON support. You can easily serialize to JSON, deserialize to JSON. Unlike XML, JSON can easily, there's a one-to-one relationship between JSON and objects. You can create objects based on JSON. You cannot based on XML. So JSON is very easy. It's compact, it's human readable, it's serializable, it has support everywhere. So that's why people are using JSON. And that's why tokens, most of the time, are JSON Web tokens, or JWT or JWT, whatever way you prefer to call them. Yeah, that's it. And so the most common use cases, again, OAuth, most OAuth implementations would use JSON Web tokens. OpenID Connect, it's a standard based on for authentication based on OAuth, and it actually, so in that standard, actually, they are prescribing to use JWT tokens. So they for sure. Or any JSON payload, anything that you want to give to someone with the information and you want to encrypt it or sign it, again, you can use JWT tokens. They don't have to be used to just authenticate and authorize. You can use them whenever you need to send data over. And so to send them, so send in JSON within HTTP request, not as a payload, but as a header or URL is not convenient and actually not possible because there's only some characters that you can have in URLs. So again, the easiest way to do that is to encode that. So whenever you see something like that in the request, authorization header, say in bearer, and then some kind of sequence like that, most likely this is a JWT token that is encoded. Right, so basically to make it compact and to make sure that it only has allowed characters, we use base 64 URL encoding. It's a standard process. So you just, again, you encode it. It becomes compact. It becomes something that can be sent in URL or in header. And most of the time it gets sent, if you use it for within OAuth and for authentication, you send it in the authorization header and it's the bearer authorization. Bearer meaning that whoever bears that token, whoever has it, can use it, right? So it's basically it's like people like to compare it to cash, right? So whoever has $100 can use those $100, can come to and then buy something at a kiosk, right? So it's the same thing. Whoever has that thing can use it to authenticate. The important thing that we'll talk about later in this session, and we'll talk about a lot, is that this thing, it's not an encryption, right? So this thing, it's an open algorithm that anyone can use to decrypt your token, to decode your token. It's not encrypted. And it can be signed, but might not be signed. Again, we will talk about that. It's just encoding. And so how do you know, in that case, how do you know that the token that you got here, like how would that resource know that what it got from that client is actually a token that it can trust, that came from that identity provider, right? Because basically, this thing, as you can see in the diagram, this API, this resource, it doesn't talk to the identity provider at all. It only talks to the client. So if the client is a rogue client, if it's some sort of an attacker pretending to be you or pretending to be a legitimate application, then how does it know that it can trust the data that gets sent? Because remember, we've decoupled it. The whole reason for using JWT tokens is to decouple it from the provider. And so the obvious way is that you sign that, right? You use cryptography. And so you get identity provider that has that JSON that it wants to let the application use. It calculates a JSON, puts whatever data about you that it wants to put. Then it calculates the signature, and it appends it to the token. And it uses the key specific to that identity provider. And your resource knows that that key. It knows that it can trust that identity provider, so it can verify the signature. For the client, so again, from OAuth perspective, so OAuth as a standard, it says that the token needs to be opaque to the client. So for client doesn't need to know what's in the token, right? Client just takes the token and passes it. So the client actually doesn't care, it doesn't verify, doesn't do anything, just passes it alone, whatever it got. But the resource can verify the signature. So let's talk about the signing process. So obviously, well, not obviously, but the resource needs to know what it needs to use to verify that signature. It needs to know what kind of algorithm is used, what kind of key is used, and so on. So either you need to agree on that in advance, or you need to pass that information. And so in JWT tokens, in JSON Web tokens, they've decided that they will be adding to that payload a header that would tell what is in there, what kind of data is being transferred, and what kind of signature is being used. So in most cases, the type of the data will be JWT, but not necessarily so. You can obviously just sign and send any application-specific data. You can, whatever, sign and send an image. The standard is fine with that. And the algorithm. So it takes that header in which it puts the information, and it just uses base64 encoding to encode that. And let's talk about the parameters a little bit. So there's a set of algorithms that you can use. You can actually the standard allows you for like debugging purposes to not use any signing at all. You can use symmetric and asymmetric algorithms, and there's a set of them in the RFC. You can send a key in the header. So you can say this has been signed with this key. So for example, you have your private key with which you sign, and the public key you just send, you can send it in the token, so the people just get your token. Or you can specify URL to that key, right? So you say, I've signed it with my private key, and for a public key, here's the URL, or here's the exact key. If you have multiple keys, you can just say, here's the identifier, use key number 5, or whatever. Again, it can be anything. The standard doesn't say what kind of identifier. Whatever, some sort of identifier that would tell the other one, use, our set of keys, use whatever, the key number 5, or the key XYZ, or whatever. And then again, for public, for asymmetric keys, you can obviously have the chain of certificates for the private key. So again, you can send information about that right in the header. So these are all related to them. And again, we talked about the media type. And sometimes the JSONs can be multi-level. So again, there's an extra header that can let you know, okay, this is a JSON, but within it there's some other media type. So you can do that. And it's extensible. So you can add your own headers, and you can use that critical set to say, for this header, I will also be sending these extra headers and the client needs to know who they are, and it needs to be able to process them. So basically, that's the set of, again, they are all optional, but that's what you send or can send to tell the API what to use, how to check your token. Anyway, so let's get back to that. So we created that header, we listed the algorithm, we've encoded that. Then we have our payload. So say our application wants to send some information about me. So it took my Twitter handle and everything. It mentioned that I'm not an admin, whatever it wants. And it encodes that as well, right? Again, same algorithm, just base64 encoding. Then it simply appends them. So it takes the encoded header, adds a dot, takes the encoded payload. And then it calculates the signature using that algorithm, and again, uses a dot thing. So in most cases, if you look at JWT tokens, that's what they're going to be look like. They'll have two dots. They will all start with EYJ, just because that's the encoding of the opening curly brackets and the quotes. So they are very easy. It's very easy to see that, yes, that's an encoded signed JWT token. There is a way in the standard to send something like this when you have multiple different signatures, and you can sign different parts of your JSON with different signatures and send them all. But that is very rarely used. In fact, OpenID Connect doesn't support that at all. They explicitly say that you cannot use that. So it's very rarely used. In most cases, 99.9%, I think. Everywhere I've seen, they use that compact serialization form that we've seen on the previous slide. This is an overkill for most people. But let's see it in action. So, for example, here's my Postman client, and I have an application, Pixie app. It's a part of OWASP DevSlops project. I call that login with username and password. I click send. It sends me back that token. It looks cryptic, but actually, if I go to JWT.io website, which is a wonderful site maintained by Auth0, so I give a quick plug for them doing that. I just paste it in here, and you can see I didn't have to provide any encryption key or anything. It decoded everything. Now it says so that it's a symmetric algorithm signed, and here's all the information about that user that the application is returning. Right? Again, it's not encrypted. Anyone can see that. I didn't have to provide any key. To verify the signature, I would need to provide a key, right? So if I scroll down, right now it says that it cannot verify the signature. It knows the algorithm, but I need to provide the secret for this thing to be able to tell me, yes, it's legitimate, or no, it's not legitimate. Because remember, the request could have contained the key to verify the signature in the header, but it's not required. It's optional. So this particular app doesn't do that. So I need to know the secret to be able to figure out whether it's properly signed or not. OK, so what could possibly go wrong? Anything, yes. So obviously, now we live in that zero trust environment, right? In most cases, people calling your API, calling your resource, are not necessarily legitimate access. You no longer, like in the good old days, in the good old days, our apps were relatively monolithic apps. Even the web apps were mostly server-side apps, right? The browser was just rendering HTML. And all the logic, everything was on the server side. That's not the case anymore. We're in the world of mobile apps. We're in the world of single-page web applications when everything is happening in the browser. We're in the world of decomposed microservices. Again, you get API calls. You don't know whether they are from a trusted person or not. So let's see what can go wrong. So first of all, yeah, I've mentioned that. You, as an API provider, you just don't trust anyone, right? You don't trust the caller. And so, and the weird thing is that JWT token, the way it was designed, put a lot of trust in the caller. And one of that, and an obvious thing is that one thing that we trust is that the whole algorithm thing, right? So so the caller tells you which algorithm they're using, and you as a consumer use that thing. But if you don't really trust that other person, then you should not probably trust that either. So there are some hacks based on that. The most obvious one is that we modify that. So remember, so I was not an admin, but I want to be an admin. But I know that they won't let me be an admin, but I really want to. So I changed that is admin to true, but now my signature is invalid, right? Because I've changed the content, so the signature is now not valid anymore. So what I can do is that I can remember that standard. It had many algorithms that supported. One of them was none, no algorithm. So I just changed that to none, and I no longer need a signature, right? And when I calculate the token based on that, that token doesn't have a signature, but it's a legitimate token. So now I can just send it, and if the client just blindly verifies the token, just saying, is it a legitimate token? It is a legitimate token. So basically, clients should not, actually most of the modern libraries, they explicitly prohibit none as the use, but you should verify that, especially if you do it yourself. Or if you use a library, again, make sure that it won't accept none as the algorithm at all. A more interesting attack is to change the algorithm not to none, but from asymmetric to symmetric. So let me tell you how that works. So we have two classes of encryption algorithms and algorithms for signing things, symmetric and asymmetric. Symmetric is when the same secret, the same key is used by both parties, right? So Sam is signing the token with the key, and then I have the same key, I have the same secret. We use whatever, his mother's maiden name as a secret, as a shared secret. And he uses that secret to sign, and I use that secret to verify. Asymmetric is when I don't know what he is using to sign. He is using the private key to sign, but we all know his public key. His public key is well known to everyone, and that can be used to verify the signature. And so suppose we are using that asymmetric algorithm to sign, right? So it's a more secure way to do things. So he is signing that with his secret key. So that's a secret signed with secret key. So now when attacker changes that, the attacker doesn't know his key. So the attacker no one knows his private key. So attacker cannot really calculate a new signature. But what attacker does is the attacker changes the algorithm from asymmetric to symmetric. However, again, what do we use with the key? The attacker is a weird one. The attacker takes the public key of Sam and uses that public key as a shared key for symmetric. So if what my code does just takes the algorithm, takes Sam's public key, and verifies the signature, that would work. Because the algorithm changed, but the key that didn't change, right? So I'm blindly using his public key. I think that I'm using asymmetric encryption. However, in reality, my code might be using the algorithm from the token, and so I'm not using the algorithm that I think I'm using. And so I think that it's all right. I think that I verified the signature. However, no, I fell victim to the attack. Or sometimes people don't. Again, a lot of developers in a lot of libraries, the decode method and the verify method are two different methods. So a lot of cases in their code, you would see that the developer is just calling the decode method, and they decode and use the data. Again, this should be a no-no. Obviously, signatures need to be verified. Or they can, again, trust the signature. We talked about some weird cases, but sometimes, again, the standard allows you to just send signature in the header. Again, a lot of libraries, you would ask them to verify, and according to the standard, they will use that signature in the header, they will verify, but obviously attacker can send their own signature, so that doesn't buy you anything. It doesn't make that code, that token any more legitimate. Also, if there are nested tokens, like you can have a token as part of the another token, obviously you need to verify signature in each and every level, right? Because you cannot trust that the first layer calling you that the second layer was correct and so on. Also in symmetric algorithm, remember when we use the shared key, that shared key needs to be something more complex than QWERTY. So, because basically the problem with that, and that's one of the issue that Louis was talking about yesterday, is that anyone can get your token. Like remember that the token that actually streamed is just passed in all the calls. So if someone gets that, they can just take it offline. They know your algorithm because the algorithm is actually in the header. They can just take it offline and just run their computer using a dictionary attack, just trying to sign that token with QWERTY, didn't work, sign it with password, didn't work, sign it with 12345, didn't work, and so on. So this should never be a word, right? This should be as random as possible, just a long random string with good entropy. So never ever use the passwords here. Okay. And keys can leak. Obviously, we all know that, right? So again, never ever have your keys in a GitHub or GitLab or anything, right? That they should not be part of your source code. Not even in private repositories, because private repositories can become public repositories at some point, and backups can be somewhere, etc. So keys are a big deal, right? If someone gets your key, they can sign anything. Yes, and obviously that not just code repositories. Again, if you have your key on the server, make sure that no one can access that file on the server. It's a hardened server, no one gets access there. Again, cross-site or whatever. Any attacks that can get a hold of your key is a bad thing. Then your whole system that relies on the token is compromised at that point, right? Anyone can sign tokens on your behalf, can do anything. Another interesting, again, thing is that suppose you're not sending the key in your, so you should never send the key in the header, but you can send the key ID. Remember we talked about if you have multiple keys, it's sort of safer to just say whatever, use key number 5, key number 3. So again, standard doesn't say what key ID is, and sometimes people use a file name. So suppose they have many keys, and they would say the file name of that key to be used. It's very easy for developer, right? You just take that file name or path, and you have the key in your backend, and you can verify the signature. However, if you just blindly trust that can lead you in trouble. For example, say I send something like that. So I just got to the parent folder, and now I got to some public information that anyone can see, whatever to your CSS file or something. So obviously, if I use that as a key for symmetric, then I know I know your key. You're going to be using the same data to verify the signature that I used to sign it. Keys, if you use keys in SQL, again, something like that, you can get SQL injection, right? Basically, if you have a SQL lookup for the key, then anyone can hack you if you don't sanitize the thing. So basically, I send something like that. I send something that doesn't exist with a union with something that I like, and this thing gets evaluated to the word key, and then again, I can get in. Same thing with the file. Again, when I'm reading the file, I need to make sure that I'm reading the file with something that is safe. So if someone sends me a command, it doesn't get executed. Now we'll talk about so that's about the content of the token. Basically, with the content of the token, just don't trust that content. Verify that everything is in line with what you expect before using them. Now with the actual use of the tokens. So suppose I have a legitimate use. I have some system that trusts that identity provider. I got that key and I'm using to access that system. That's the sort of the normal flow. Suppose there's another system that also trusts that same provider, right? So that, again, happens all the time. If we talk about whatever, everyone trusts in Facebook, that would be the typical situation of different companies trusting Facebook for the tokens. Or it can be even within your internal deployment. You have multiple services that trust the same identity provider. So suppose that's a rogue user. And that user actually wants to go and access this organization. So if my key only contains information that the user is Joe and his role is admin, and these two systems both happen to have a username Joe, and they both trust this guy, this identity provider, then nothing prevents that malicious user for using the token that he got for this organization and use it with this organization. Make sense? Yeah. So again, you need to make sure that that this organization needs to know that the token that this user is using is not for this one, but for that one. And for that, there's an optional parameter, audience, that you can use. And then I would encourage you to use. And so your token should contain information about who the user is, who the identity provider is, but who the audience of that is as well. So you don't accidentally take the token from that was issued for someone else. Similar kind of attack would be if suppose you have some mail server and a finance server within your company, and you send something and you verify that the audience is anything in your company, like my.org /star. Again, don't do that. Don't use wildcards. You can easily get someone to use your token that was intended for one system to another system. Be specific. Wildcards are allowed, but should be discouraged. Or someone can just intercept your token and reuse it. So for example, I want to access some tokens that was issued for for Billy. I'm not Billy, but I just happen to have his token. Why shouldn't I use that token to just do anything on Billy's behalf? So that's obviously bad. So for that, you need to limit the tokens as much as you can. So there's a way to produce timestamps, say when it was issued, say when it should expire. You should obviously set whatever audience and everything. There's a way to add just unique IDs to prevent tokens to be replayed. Use minimal scopes. Again, don't use all-powerful tokens. Try to use the tokens that are only specific for this service and that only have the information. So worst case, if it leaks, again, the worst case scenario, they would use it within what they were supposed to use. And make it specific to client as well, right? So if you have a way to identify the client, for example, it would have embedded certificate. You can use it with it. You can tie it to the TLS connection or anything. Use that as well, right? So another client could not use it. Now going back to opaqueness of the token, right? So we talked about the token that the client should have no idea what the token is, right? However, in reality, if it's a JWT token, in reality, a client is supposed to just send it over. But nothing prevents the client from being a rogue client and decoding it, right? So if your token contains some information that is sensitive, credit card information, user birth date, whatever is the information that you don't want to leak, his phone number or something, then this can leak if it's in a token, and the client is a rogue client, right? Because it's not encrypted. So there are two main things that you can do about that. One thing is that you can use encryption. So we have less than 10 minutes, so we will not talk a lot about encryption. But basically, the same way that you can do sign-in, you can do encryption. It's obviously, it costs something. There's more compute involved. But you can do, again, you can add the encryption algorithm to the header, and you can use that algorithm to encrypt the key with which you can encrypt the payload later on. And it's a symmetric algorithm going to be used for encryption, but asymmetric for the key. But it doesn't matter. So basically, if you get something that has 5 parts and 4 dots, then this is an encrypted token. So for example, I have a developer account with a Spanish bank, BBVA. So when I send a request, this is the kind of key that I get from them. So that's way longer. And you can say that they give me some unencrypted data outside of the key. So for example, they tell me my scopes and when it expires. But everything else, if I were to paste this into JWT.io, I wouldn't be able to get anything out of that. So we've done that. The other solution is to do different kind of tokens. And this is something that a company called Curity is promoting, and they've implemented. And they call it phantom tokens. So basically, the idea is that you have the normal flow when you request your token from identity provider. However, that token, they say, well, make that token as silly as possible. Just give some sort of unique ID. So if the token leaks, the outside client doesn't get any information from it. However, then have some edge server that exchanges that token with a real token that has real information. And so then inside your application, inside your Kubernetes cluster, inside your network, you use a full token that has a lot of information about the user. Outside, it's something that if that leaks, it's just a temporary UID. No one cares. It's going to expire, and then it's going to be a new one. So the advantage of that is obviously that you limit the exposure to the outside world of the information in the token. So you're limiting your exposure and attack surface. The downside is that, well, obviously it's an extra hop, right? So we are talked about the decoupling. Well, here we're not as decoupled anymore. So there are pros and cons. However, just keep that in mind. And obviously, if you have another layer here, you could have token exchange happening multiple times. And that's totally fine. And that's the way to have multiple layers of defense. Finally, I love that quote from Abraham Maslow. If the only tool you have is a hammer, you tend to see every problem as a nail, right? So JWT might not be what you need in your application. Just yesterday, one vendor, a guy from one company was telling me that, for example, they tried putting everything in token, and most web servers have 8 KB as a limit for HTTP headers, and they ran out of space in HTTP headers, right? So just keep that in mind. You don't, because you have that tool at your disposal, doesn't mean you have to use it for everything and send all the information. For example, I've seen a lot of web applications now starting to use tokens as a cookie. Can be an overkill. Maybe if you're doing a web application development, it might not be the right tool for you because it's much larger. And in most cases, remember that the idea behind the tokens is that you have the state in the token, so you don't have to do database reads or whatnot. But most of the web applications, they would still use a database to load some information about the user and some customer-generated content and so on. And in that case, if you're going to be using a database anyway, then JWT makes no sense. You just need some ID of that user, of the session, and the cookie is as good as a token in a cookie. So it doesn't buy you anything. And again, lots of modern web frameworks, they load users on any request anyway. So again, you have double loads without and double verification of signatures anyway, because cookies are protected regardless and so on. So it might not be the right tool for you. So just don't blindly use that technology because it's cool and others are using. And again, so most likely to optimize things, you'll get better bang for your buck with caching and other side optimizations. So let's go back to recommendations in general. Again, make sure secrets are kept as secrets, right? If your secrets leak, your tokens are not good. Make sure that, again, external communications are opaque. If you cannot trust the client, don't trust the client, right? And encrypt the data or minimize the data that you send. Make sure that you use, when you verify the tokens, you use the specs or you use the library that uses the specs. So you actually verify that all the fields are the way that they're supposed to be. If there's a URL in the field, that URL points to something trusted and not to a random domain. Can be very tricky, especially in cases when you have some sort of multi-tenant deployments. Microsoft had that issue in Microsoft Online because someone could host a website on Azure and get a domain name something.azureapps.com, and people use that to hack into Microsoft login system, right? Because they could use a legitimate looking Microsoft domain that for some code verifying within Microsoft, whatever they call these days, Microsoft Passport, whatever it is now. It just had some URL, the URL implementation was just checked for the end domain, for the top domain. So make sure you validate everything. Finally, as a final thing, I'll talk about a little bit, 2 minutes, on what for 2Crunch, the company I work for, is doing in terms of externalizing some of that verification process. So since we are doing API security and API firewalls, in API world and REST API world, there's actually a way to define your APIs programmatically as what used to be called Swagger files. Now it's called Open API files. And there you can basically define the API itself, all the paths, operations, parameters, their patterns, and so on. So what we have done for our customers is that we have added, so that format is extensible. So we've added extensions. So within the API definitions, people can define not just the API, but also JWT requirements. So they can say in that file, and it's just a YAML or JSON file, they can say that this requires JWT. JWT going to be passed as a header access token. It needs to use RSA only that algorithm or whatever one of these two. And the key to verify that would be in the environment variable, that name, and so on. So basically, the idea is that you can externalize the checks by having them within the API itself. So it's basically kind of security as a code approach. You can also do some JWT verification in Envoy if you're using Envoy. So Envoy has a subset of that. So if you're already using Envoy, again, some of that JWT verification can be externalized to Envoy. So externalizing your policies and your verification is obviously a good thing because you no longer have to trust each and every developer in your company to do each and every check. So externalize the checks as much as you can, whether it's in the external tools like API firewall or Envoy, or libraries that can be trusted, and you just verify that it's a proper library used in a proper way. There's going to be a bunch of links in the slides when you get them. Other than that, we have like 3 minutes for questions.
Thank you, Dmitry. If you have a question, just raise your hand and I'll hand you the mic.
For encrypted content, is it okay to use the same key for encrypting the content and signature validation?
Oh, yeah, so excellent question. So the good thing about encrypted tokens, JWT tokens, is that the encryption algorithms supported by the standard actually have encryption and signatures and verification within the same algorithm. So actually, when you use encrypted token, you do not have to use a different algorithm to sign. So
the same key.
It's going to be the same key, and it's going to be within that long five. Okay, here it is. Come on. Oops. So this thing would have authentication tag, and basically, in just one go, when you encrypt it, you get both the encrypted content and you get the signature within one go. And then when you receive the token, again, within one decryption, you both decrypt the payload and verify the signature. So you don't risk someone just messing around and somehow accidentally coming with a valid payload with invalid signature. That's not possible.
So the second solution that you gave was the phantom keys?
Yeah.
Phantom tokens, sorry. So how does the tokens map to JWT? How is the mapping of one to another?
Okay. So basically, the mapping has to happen somewhere in the identity provider.
Is there a standard way to map it? Or
It's not a standard thing.
Okay.
It's an approach rather than standard.
Okay.
It's just an approach saying, don't send the whole information, send some kind of identifier, and then have your own code that would somehow have a mapping between that identifier and the thing. But don't use permanent identifier. Use some kind of temporary identifier. So if this thing leaks, it's good for whatever, for 5 minutes or whatever it is. But you have that mapping internally. Well, thank you so much.